it brought me to a site asking me for if I want accelerated mode or detailed mode.
Yeah, you're good. That's where you should be.
Right, that's where you should be. That's the landing page. So hold on to that page.
Yeah.
Okay, cool.
Hi.
Hi.
I was wondering, what kind of mode do I select?
Just hold on. Once we start, you just follow us. You are on the screen, blue screen that says accelerated mode and detailed mode.
Yeah.
Yes, just wait a couple of more seconds.
Okay, I still have to download the data set, right?
Yes, you have to download the data set.
Yeah, so just to clarify, if you are on the screen that is letting you choose between accelerated or detailed mode, that's where you want to be. So just kind of hang around there.
Do we download the training data or the test data?
Download both.
Both.
Are there a lot of people?
I just came. What should we do right now?
So if you follow the steps and you're on the screen that says accelerated or detailed mode, then you're good. If you haven't followed the steps yet, just kind of follow the steps on the screen. We're going to get started in about a minute.
Is it okay if we use our personal Google account, or should we use the Princeton account?
It'd be preferred if you use your Princeton account. It's if you strongly would not like to, then you can go ahead and use your personal, but we prefer you use your Princeton.
Okay. But it's not like, could I have access to this service after I graduate with my personal account? Is it like free and open to everyone, or?
Yeah, so I think I would imagine that there's going to be communication from EazyML to you guys after the workshop, and so you definitely be able to put that inquiry in and say if I need to transition to using my personal account, like I'm sure that EazyML would be able to make that work. Yeah.
Which one mode should we select?
Once you've reached accelerated or detailed mode, once you reach that screen, just hang there and wait, and we'll get there. So what you want to get to is the screen that allows you to choose between accelerated or detailed mode.
Okay.
Okay. I think we'll get started. Probably a few more people will roll in. And if you're kind of coming in right now, just follow the instructions on the screen, and just one more time, once you get to that screen where you got to choose between accelerated or detailed mode, that's where you want to be. And then make sure you download the data set and download both the train set and the test set. Both of those are going to be used over the course of the workshop. Cool. So my name's Arjun. I'm the president of Princeton Data Science. So just a little bit about Princeton Data Science. We're an organization on campus that seeks to promote data science on campus through various means. We have many divisions, and through those divisions, we bring speakers on campus to talk about how they use data science in their work, either in industry or academia. We also host workshops on campus or through Zoom, as it is these days. And then the last thing we do is we help organize student collaborations on projects and competitions. So hosting events like these is kind of our bread and butter, and this is what we really enjoy doing, bringing data science to students on campus. So that's a little bit about Princeton Data Science. If you want to learn more, you can check out our Facebook page, facebook.com/PrincetonDS, or our website, princetonds.io. So I just wanted to give a brief introduction to EazyML. So EazyML as a company, their mission, and they will speak more about this, so that's why I'm going to be super brief here, but the idea is to create a transparent, simple, easy to use, and yet still powerful platform for people to build machine learning models. And it's not necessarily people who have deep experience in machine learning and are doing research in machine learning, but even those who are kind of getting started, those who are less experienced. And so as a result, this platform is kind of one of a kind in the sense that it provides both this balance between ease of use and a lot of power, especially when it comes to textual data and analyzing free-form text. And so we'll kind of see how that works as we go through the workshop. So that's really exciting what they do, and we're lucky to have the CEO, Deepak, the CTO, Pranay, and the head of business development, Meeta, all on the chat, and they're all going to be helping walk through the workshop today, and they'll be introducing themselves shortly. So we're really lucky to have them here. EazyML has been working with Princeton Data Science for a long time. They approached us back in the fall, and we've been planning this workshop for quite a while. In fact, we've been planning this for so long that the original plan was to have it in person. So, so it has been a while, and we're really excited to bring this to fruition. And so with that said, I'm going to pass it over to Meeta, I believe, to explain a little bit more about EazyML. And I'll kind of be jumping in as well during the workshop, and you can message me privately or message the group chat as a whole if you have any questions. So, cool.
All right. Well, thank you. Welcome to EazyML workshop. Thank you so much, Arjun, for organizing this. You've been very, very helpful. We're really thrilled to host this workshop for Princeton. This is the first in a series of EazyML workshops that we plan to do with the Princeton Data Science Group. We'll be hosting also competitions and challenges and prizes. So it's going to be a lot of fun stuff, and learning EazyML, learning machine learning through EazyML. So a little bit background about EazyML and the company. As the name says, EazyML, it's really easy to use, easy to learn machine learning, automated machine learning platform. So our vision was learn machine learning by doing machine learning. And we want to democratize machine learning. So you will see today through the workshop that even for those of you who do not have a data science background, you can learn machine learning by using EazyML platform. EazyML, the company was spun off from a global company called IPsoft. They have an NLP platform called Amelia, and you can Google IPsoft space Amelia, and you'll see that it's a very, very highly rated and world-renowned NLP platform. And thanks to our lineage, EazyML gets its NLP power from Amelia. So we have very strong NLP power in EazyML platform.
Oh, for those of you, NLP means natural language processing, right? So from a data science perspective, you can kind of refer it as text analytics, unstructured text analytics.
Yes, thank you for that interjection, Deepak. And the last really differentiator of EazyML platform is transparency. I'm sure all of you have heard about explainable AI. EazyML really explains its predictions, really explains beyond the current state of art too, which is Lime from the University of Washington. And to the best of our knowledge, EazyML is the only platform that tells you what it's doing to its data in context. So those are the three strong points of EazyML. Easy to learn, learn machine learning by doing it. Really strong NLP, natural language processing, and transparency. So having said that, I'm going to introduce you to Deepak, who's the CEO of EazyML, who'll say a few words.
Hi, guys. So please, like Arjun said, ask away. Interrupt us at every possible question that you got. Don't shy from asking. The more of a dialogue it is, the more we all will learn. I know you come from various interdisciplinary backgrounds, right? And you've studied lots of studies all your life, theories and studies, and sometimes you wonder, how accurate are these studies? It probably tickles your curiosity, right? How do you find that out? And now you can, with the help of this platform. Here's how. Let's say you want to verify something, or you want to check your understanding of something. Well, you conduct a small experiment, gather data, do ML, train machine, intelligent statistical machine on the EazyML platform, then have the EazyML provide insights. Now that's the key. Provide insights objectively from data to confirm whether or not the data aligns with what the studies that you've been learning have been saying all along. So there you go. Now you can actually use your own small little experiment to have a machine tell whether that data is aligning with what you've studied from a research publication, for instance. So I'll give you a couple of quick instances, right? Let's say a study claims that NoSQL, a database system, performs 5x when compared to relational database systems. Let's just say there is a study that claims that. And you are a computer science major and thinking, really? How do I check that? Well, run an experiment for different data sets organized in different formats on both of these, NoSQL and a relational database. Use the data you've gathered to train EazyML, and then have the platform tell you as to give you the insights as to under which load does one perform better than the other. So now that data becomes alive. It's actually telling you a story. These types of conditions, NoSQL performs better, but under those types of conditions, relational database performs better. Some of you may be from social sciences, I'd imagine, and we've heard that, for instance, here's a simple experiment there. You've heard that humans are social beings, right? By the way, take the fifth. I'm not a social science. If this sounds silly, please don't abuse me. So we've heard humans are social beings, and obviously during the lockdown, it brings it more to the fore. Are Princetonians social? How about you conduct a survey? Gather some data. Train EazyML. And let it tell objectively from that data whether or not that theory, humans are social, works at Princeton. See that? So please, I would urge you to observe carefully when our colleague Pranay takes you through the EazyML platform and discusses what's known as, in machine learning parlance, explainable AI. It's a key facet of EazyML's transparency that you can use to gain insights into the world you live in. So over to you, Meeta and Pranay. Did that make sense, guys? And any questions, comments, feedback?
Wait, so I'm basically saying that in some situations, data can be false or true.
So let's say you've read a study, right? That's claiming a particular that's claiming a particular position. And you're curious, is that study accurate? How accurate is it? Under what conditions does it hold? What if I change the assumptions slightly? Does that make the whole study blow up in the face? You have all these questions. So how do you go about verifying, cross-check, and validating it? So one way is to use machine learning on this EazyML platform. Why? It's a transparent machine. Gather data, train the platform, have it give you insights into that data. Objectively tell what that data is saying, whether or not that it holds under these conditions. It's going to give you those insights as it's making its predictions by being very transparent and explainable about its predictions.
That makes sense.
All right, cool.
All right, Pranay, it's all yours.
All right, thank you, Deepak, Rita. Hello, everyone. Very good evening to you all. Before I begin, let me just do a quick poll. How many of you already have data science background? If you could just raise your hand on Zoom, that will give me an idea as to how deep to go into the concepts versus whether to stay at the high level. All right. So we do see a few in here with the prior data science background. Actually, quite a few. Those who are raising their hands late. Okay, there are quite a few in here. So some of you are already familiar with the terminology, while some of you may not be familiar with the terminology. So for the benefit of non-data scientists, I will introduce various terms in here. So what is EazyML? It's an AutoML platform. And what is an AutoML platform? Well, when it comes to machine learning, the objective is there is a challenge at hand. We are going to study Titanic data set. I'm sure most of you are familiar with what that data set is about. The ship sunk a long time ago, a giant ship. This study is about those who survived. What were various attributes? What kind of population on that ship survived the disaster? So that's the study to be conducted. What we want to know is, can we mine some insights from that given data set as to whether those were specific gender, male or female, who survived, those who were into certain age range, they survived, or those who paid more, did they survive? We don't know. Let's say to start off with. Okay. So that's the data set. So data set is the term where you have data collected. Like Deepak mentioned, you are doing a survey, you are collecting data. You could have many data sets. The EazyML, the platform, is right here in the center. You feed, we will feed the data set to the EazyML platform. As part of the platform, there are three distinct stages. And any machine learning scientist would know that these are the three stages that you have to go through. The first one is a challenging one, preparing data. Once you have prepared the data, you got to cleanse it, remove the outliers. There may be missing values depending on the study you are conducting. Some of the records in your data may not be filled in completely. Maybe they are filled in partially. So depending on the study you are conducting, maybe you want to discard those rows with the missing values. Or maybe you want to just extrapolate and fill in those missing values. So there are various steps in the data preparation that precedes before you could actually build models, which is, in machine learning terms, you are training a model. Now, what is a model? It's a mathematical abstraction of what this data represents. In some ways, physicists are the true data scientists. They model the nature. Whether it comes to Einstein from Princeton model the energy and mass into a very compact formulation. What you observe in nature, collect all the data, and come up with a mathematical formulation. In that sense, what we are trying to do is take data sets from various studies, experiments in a specific domain. It could be a finance domain. For example, you want to predict the stock prices, or maybe mortgage industry. You want to predict whether this borrower is going to perform a default, or real estate prices prediction, all kinds of challenges in the real world. Okay. So we are going to build a model, train the model based on the observations that you have collected over time. And the final stage, you want to run predictions on these models that you have built. Now, when I say models, there are multiple models you can build. And there are several ways in which a relationship can be expressed. In fact, before physicists arrive at a specific formulation, whether it's Michael Faraday or Einstein, they must have been through several other mathematical models. The same way here, it's an iterative exercise. You build all kinds of models and choose the one which best represents the reality of your study, which best fits your observations. And once you have chosen the best model, that's the one which you use to derive predictions. So that's in a nutshell is what EazyML, the AutoML platform, facilitates you to accomplish. So with that said, let me switch over to the portal that everybody has signed into. Just give me a sec. I'm gonna switch over to the portal in here.
Everybody should follow now. It's the accelerated mode. Oh, sorry, it's a detailed mode, and everybody should follow along with Pranay.
Right, so those who have signed in and logged in, this is the landing page. Now, there are two distinct modes, accelerated mode, detailed mode. For the beginners, I would recommend we start with the detailed mode, and for the purposes of demo too, right? So you click on detail mode, and then we will walk through every single step that machine will take you through. Now, there is another advantage of the detail mode. Since it's an AutoML platform, the platform, EazyML platform, is going to make many decisions for you along the way. It's going to recommend those decisions for you. Now, it's up to you whether you honor the platform's decision or override it. In detail mode, you get to override it. In the accelerated mode, you're basically telling the platform, I trust you. Please take me through the entire pipeline in minimum number of steps with your own recommendations. So here we are going to choose detail mode. There are a few other things in order. Anytime you have a question about a specific stage in the machine learning pipeline, you just click on the question mark here on the top right. It's going to give you help specifically about that screen and maybe in the context of the data that you have uploaded.
Yeah, and that's the key, you see. That is where you learn machine learning by doing machine learning. It's not just, well, trust us, whatever the platform's doing, and it's going to give you some results, and that's it. You take it for what it's worth. You can click that question mark and say, why the heck did you do what you did to my data? What's the theory behind it? Give me some details. And that's how, as you go through it, you will become the experts yourself at ML.
Right. Right. So machine telling you every step of the way what it's doing with your data, that's the aspect of transparency. So when we talk about EazyML, another platform, so transparency is the key theme that we talked about. We'll come back to that another point. So let's choose the detail mode. And over here, you have three distinct phases that we talked about. Prepare your data, then train on your data to build a model which will represent the characteristics of your data so that you can run your predictions in the end. By the way, at any point of time you want to abandon this flow and start all over again, you can always click on the home button. Okay. So we are going to upload a data. So there are these
Can I
choices.
ask,
Yes, go ahead.
I have a question. So, what's the difference between the three options on the previous page?
All right. So on the previous page, so like I said in the machine learning, the exercise, there are three distinct stages. You prepare your data. So that's the first stage, upload training data. The second stage is you build model. And the third stage is predict your work. But this platform allows you to do these stages at your own pace. Now, for example, you got multiple data sets. Okay. You upload a data and maybe you want to do model training maybe a couple hours later because you have really fast. So what would happen once you upload your training data?
No, it's fine, it's fine. Next time, just don't get it if they don't have it.
You are
so thank you
asking any questions. Could you guys please put yourself on mute? Thank you. So that was Anika asking question, right?
Yes.
Okay. So let's say you upload the data set, you want to build the model a little bit later because you have a class coming up. So you go through the stage one. Your data set would be available to you in this directory. Okay. This is where your data set becomes available. As you upload data sets, they become available here in the directory. You can come back to this at any point of time and just build the model, right? Or maybe you can come to the landing page and say, I want to go to directly building model because I uploaded the data about a couple hours ago. So that's all this screen is about. You can go at your own pace with three distinct stages in the machine learning exercise. So we'll go with uploading your data set. That's the first step. Upload a file from your device. If you have a Google account, you may have Google spreadsheets or CSV, Excel files saved on Google Drive. You can upload directly from there too. I have the Titanic data set downloaded on my local computer. That's what I'm going to use. Upload file, pretty basic stuff that I'm showing you here. Okay. Data set, I've been playing with this data set this morning, so that's why it says duplicate training data set. I'm just gonna override, rewrite.
Yeah, like Pranay is explaining, guys, we want to train the machine first so that it recognizes and becomes intelligent about your world. And that's done through training data because this is supervisory machine learning. And so he's uploading the training data as a file. In this case, probably an Excel spreadsheet, right, Pranay?
That's right. This is an Excel or CSV file that you can upload. So Titanic data set is what you're looking at here on the screen. All right, so in this data set, several features. The first column, of course, tells you whether the passenger survived or not. So when we say training data, the training data is what with which the machine is going to learn about your data. So you are telling the answers in a way. When you are building model, here are the features of this particular passenger, Mr. Owen. Okay, he was a male, 22-year-old. He did have a family on board. He paid basically the third-class fare in those days. Did he survive or not? Well, the answer is yes, he survived. So when you're training, you are giving the answer. So in the machine learning terms, these are called outcome labels. You are giving labels. You are giving label data. This is a supervisory machine learning platform. So in supervisory learning, you feed label data to the machine learning exercise. So that's what you are looking at in here. Right? And again, this is table navigation, basic stuff. You can click through pages, you can search, sort, filter if you wanted to do study on this data. Now, if you do have an identifier variable in your data, we recommend you provide it. Which one is it? Typically, the identifier doesn't play a role in the outcome prediction. Whether it is Mr. Owen or Miss Maria, it doesn't matter. The the outcome depends on the other features. So I provided the ID. Discard columns is, let's say if you have a large data set in different iterations of the experiment. In some experiments, you want to include some features while you exclude some others. This screen allows you that flexibility to include or exclude.
Yeah, just one thing to add to what Pranay said. Suppose you are looking at a screen and scratching your head and say, what should I do? You hit the question mark button. It tells you that this is what this means. And this is why the machine recommends this to do at this stage by default. As a first step, it's relatively safe and a good choice to go with the machine's recommendation. It's based on statistics. Of course, if you are well along in your data science journey and you say, no, I disagree, and I'm going to overrule the machine, feel free to do so. So in the previous step where Pranay removed the name, let's say you weren't sure. It's like, I don't know, ID is a key field in a database. Yeah, that primary keys don't really have predictive power. So should I get rid of that? I guess I should, but maybe not. So stick with the default recommendation. You'll be fine 9 times out of 10.
Right. Right. So as part of the stage 1, data preparation, machine has prepared.
Oh, I'm sorry, Pranay. 2 people raised hands. Any questions? Nathan and Omar?
Sorry, I just left my hand up from when you were asking.
Oh,
yes.
Okay. Okay.
All right. No worries. So the data types for various features automatically determined by the machine. So if you have a large enough statistical sample, the platform is going to be correct most of the time. So here, the data types determined for various features, they are all correct. So we'll just go with the machine's recommendation.
Right. And just
now,
to
if you
chime in
want
on
to
what
go
these,
right, sorry.
Just to chime in on what these mean, sorry, Pranay. So categorical feature usually means that there's only a sort of a limited amount of values that variable can take on, right? So for example, with something like P class, which is the class of your ticket, there's only 1, 2, and 3. There's only 3 possible classes. So we call it a categorical variable. Whereas something like age can take on much more values. So we call it a numeric variable, right? It doesn't really take on necessarily a very small amount of value. So that's kind of what we're doing here, is classifying these variables into different data types, either categorical or numeric.
Yeah, well summarized, Arjun. And Pranay, if you can hit that question mark, what Arjun said is exactly coded there. So anytime, let that be your friend as you learn machine learning.
Right. Well, thank you both.
One question, actually.
Mm-hmm.
So why would then siblings/spouses aboard and parents/children aboard be considered categorical and not numeric?
That's a good question. So because there are, like Arjun explained, that particular feature could take only a handful of values, right? Maybe 1 family member, maybe 2 family members, up to a certain limited number of family members, maybe at most 5, a family of 5 traveling. So the way categorical is determined is by, how many distinct values, unique values, that particular feature can take. Now, to your point, if you disagree, or maybe for your particular experiment, let's say it's important that this should be treated as numeric, then all you have to do is just click on change, and that data type will be changed to numeric.
Okay, thank you.
All right. So we keep moving. The basic statistics for your variables. So all the numeric variables, you will have the standard statistical metrics, mean, median, max, standard deviation, all that stuff will be available for the numeric variables. The others, the categorical, are date. There is a date time type as well. There is textual type, because one of the key features of this platform is its ability to allow you to mix the categorical data, numerical data, datetime data, along with the textual data. Those textual data could be, for example, a paragraph passage from a textbook. It could be reviews posted on internet, let's say. Or for example, let's say you're doing stock price prediction, right? You believe that stock prices fluctuate more, especially Tesla stock prices fluctuate more based on not what Tesla is, whether Tesla is making money or not, but based on what Elon Musk tweets. So you want to consider Elon's tweets in your Tesla stock price prediction. So you go to Twitter, use their APIs, the Firehose APIs, pull in the tweets about Tesla, maybe about Tesla from Elon Musk, and then combine that data with the regular financial data that you may have about Tesla, and then feed it to this machine learning platform. It allows you to do that. Unlike in most other platforms, you would work on the textual data separately and numeric and categorical data separately, and then bring together the outcome from two different experiments into one. But over here, you could have all that combined into single experiments. In fact, the next data set that I'm going to show you just demonstrates how that is possible, how that is to be done. So we'll keep moving to remove the outliers. If you are from data science background, you understand what it is. For non-data scientists, well, as the name implies, outlier in English, that's what it is. These are extreme observations, right, in your data set. And you are teaching a machine from your data set. You don't want to mislead the machine. So if there are just a couple here and there extreme observations, that may throw off the machine. So machine is learning the norm, right? What is the norm? If you throw in those deviations, extreme deviations, the machine may get confused. So make sure if it's not outlier, well, on the other hand, if you believe those are not really outliers, it's important for my study. So you can always override the platform's recommendation from yes to no, right? So we are going to go with the default recommendation in first go, but you can run experiments several times and through the entire pipeline and override decisions as you feel right. So here is the data processed with outlier removal in every stage completed. We are almost at the end of stage one, but there is one thing, one important step that you have to perform is to identify what is it that you're trying to predict. Okay, in this study, I'm trying to predict who survived. Okay. Well, for fun, you could have other experiments, whether you may want to predict a passenger class, maybe fair, no. But for this study, I'm going to predict who survived, right? So this is just the summary. 861 rows, 6 native predictors, outcome is survived. Visualize the data, I'm going to skip in the interest of the time, but you can do 2D and 3D visualization of various parameter combinations here.
Pranay, time check, just.
Yes, I'm at the end of stage one. Thank you, Meeta. Stage two, well, when you completed stage one, by the way, your data set would be available here in the directory. Okay. At this point of time, if you want to take a break or go to a class, you could do so, come back to model building later. But here we continue.
And one quick thing about before stage two, training data for machine learning is the most important ingredient because you are the teacher and training data is teaching the machine. So the machine's been diligent. Hey, the teacher could be wrong. I'll remove the outlier. Sometimes the teacher doesn't teach me right things. So it's trying to be an intelligent student. But on the whole, it's relying on your training data. And as practice of ML shows, training data suffer from lots of issues in practice. They are incomplete, meaning, hey, there are 3 other things that could have influenced, in this case, survival that are not considered. You should have included them. There's no way the machine can predict well now as well, because you're missing some important parameters that play a role. There are holes in them, right? Oh, there are some values that weren't recorded. Forgot to record them. So now what should the machine do when it encounters these holes? Neglect those records? And even worse, it's got bias in them. And those bias end up reflecting in the ML models. So please take all the time in constructing your training data. The better you do it, the more insights the machine will provide into the world that you are trying to understand. Thanks, Pranay. That's it.
Thank you, Deepak. So here we are beginning our journey in model building. Two kinds of models. Predictive models have to do with predictive analytics. You are trying to predict either a category, survived or not survived, or maybe you're predicting a stock price, in which case it's a regression problem, right? So in predictive analytics, two kinds of problems. Classification problem, where you're predicting one of the classes, survived, not survived, whether the performance was satisfactory, good, poor, three categories. So whenever you're predicting categories, it's a classification problem. Whenever you're predicting number, it's a regression problem. Versus time series is trending, basically. And you can find all those details in the help section in here. Right? So we'll go with the flow classification because the outcome is categorical. Do we want to remove dependent predictors? Well, in your experiments, you may decide to. The machine's recommendations is no, for good reasons. Adding numeric derived predictors, no. So for example, you're working on house price prediction problem, right? And you have multiple numeric predictors in there. Let's say square feet of the living area is one of the predictors or one of the features. Square feet of the lot, you know, those two are given to you separately, but you want to construct a new predictor called the ratio of living area to the entire lot size. Maybe that plays an important role in the house price prediction. So this screen, if you said yes, allows you to do that. Construct your own or rather derive additional predictors which are not there in the original input data set. So that's very helpful. We'll keep moving, feature selection, and after that, just before we build the model, a quick preview of the data set. If we had derived the predictors, then they would show up in here as well towards the end. Okay. Did anyone have a question in here? All right. I thought there was someone.
I have a question.
Yes.
So could you go over when we would need to have the derived predictors?
Or when would you need to have to derive predictors, you're saying, right? That's the question. Yeah. Right. So the example that I gave you about house price prediction. So on Kaggle, there is that data set. We will have it on our website also at some point. So when you believe that your model's accuracy, for example, here, when we built the model, the best accuracy came out to be 82%. Well, the model can learn only from what you feed. Maybe you're not feeding all that is required to predict, maybe all the way up to 85%, 90%. What is it that's missing from what you're feeding into the training process? Right? So when those questions come up, that is when you think about, should I add derived predictors? Or should I bring in predictors from somewhere else, additional predictors? For example, if you're predicting stock price, you got all the predictors from a specific data source. Now your stock price prediction accuracy is just about 67%, let's say. So you are missing some important predictors. Maybe the oil prices should be brought in as one of the predictors. Maybe volatility indices should be brought in. Maybe consumer sentiment indices should be brought in. So that's when you start thinking about whether to bring in more predictors or derive from what I already got.
So to add to what Pranay said, here's when you should think in terms of derived predictors, right? Let's say you are trying to predict dropped calls for a mobile network. Any of us who have been to New York City and are AT&T mobile subscribers know that that's a perennial problem. All right, so it turns out that dropped calls are a function of the rate at which traffic is hitting the mobile network. Okay, so now your native predictor maybe you have these timestamps between which you've recorded how many calls came in, did they complete or not, how long was the person on the call talking, what was the disconnect cause, a whole bunch of things, right? As predictors, as variables, as variates, as we call them, right? Now, none of these have the predictor that says this is the rate at which calls are arriving into the system, right? Classical queuing theory, right? This is the rate at which calls are arriving into the system. But that is the key to dropped calls. So what you need to do is derive that predictor, right? You need to take the number of calls serviced divided by remember there is a begin and an end timestamp for that particular record, divided by the end minus the begin timestamp. Now you got the rate. That derived predictor would have outsized influence on the stuff that you are trying to predict, which is the drop call ratio. If you didn't do that, then you are requiring the statistical model to make that inference. Not always easy to do that. Try doing a simple division using a division using neural networks, and you will find that it's not always easy to do these things because it consumes real estate on your model. So in that sense, the reason Pranay said no to derived predictors is because the machine is not the subject matter expert. It had no way to make that determination, right? And so what it did was it would use brute force and try and combine various parameters. But if you are the subject matter expert, you know what matters, then please do that. It will help improve the accuracy of the machine. Hope that helped.
Yes.
Yes.
Pranay, time check.
Yes, we have about 10 minutes and we are almost towards the end of the second stage. Here we built several models, and the data scientists are already familiar with most of these terms. But these are basically mathematical formulations, algorithms, which are running in the background with various parameters. The machine has explored through the entire space of the algorithms with hyperparameters, and came up with the best. Now, if you read about this particular data set, on various places, if you read up about this, you would notice that if you scored 81% or so, you are in the top 95 percentile. And this platform got you to that in just one step. You can do a lot more with the platform. For example, if you are into programming, there are options by which you can click on the developer portal, and then there is there is configuration option in here. You can, for your particular session, you can say that I wanna enable hyperparameter tuning, okay? Or you may play with some of these configuration parameters in here, in addition to what the EazyML platform is recommending you on the screen. So programmable portal, where you can play with the hyperparameters configuration and maybe try to boost the accuracy further. As it is, you are beyond the 95th percentile.
Yeah, just to chime in and clarify, so hyperparameter, each of these models will have a bunch of parameters that need to be tuned. And so, for example, if it's a decision tree, like how many variables are in that tree, how big is the tree, things like that. So there's so many things that need to be tuned. And so what EazyML does in the background is find the best selection of the parameters for each of those models, basically the selection of those parameters that will lead to the highest accuracy. And so if you want to have control over that as a developer, you can actually choose those parameters using EazyML's developer edition.
That's right. Thank you, Arjun.
Pranay, could you show the transparency piece so that?
Yes.
Thanks.
So here, these are the important predictors, the insights in the decision making, or predicting the outcome, whether someone survived or not. These features play an important role. Whether you are male or female, the gender plays the most important role. So that's the fine. And then of course, which class you traveled in, how much fare did you pay, what was your age, they play the secondary roles in here. All right, so model is built. It's available to you in your directory here. You can always go look at the models built in here. We will now continue with predicting on a data set. By the way, you can choose any model to predict. Okay, the machine will recommend you the best one. Okay, but for your experimentation, you can choose any one of those to predict. Again, upload the file, test file here. The test file we have from this EazyML portal that you downloaded. So I have downloaded here as well in the downloads, Titanic test data. It's gonna run the predictions, it's ready, and you can look at your predictions in here, right? Prediction whether it survived or not. The last column in green is where you will see your prediction results. Now here is the cool thing. We talked about transparency in the beginning, right? There are so many machine learning platforms out there. Among those, there are a few which are AutoML platforms. Why another one? Well, this is what sets it apart, the transparency.
A quick thing, Pranay, really quick.
Yeah.
In the test data, please don't populate whether or not survived. That's machine's job now. It's being trained by the training data. So it should be able to make those intelligent predictions. In your training data, obviously you needed to put survived or not, 1 or 0, so that the machine could train, right? Learn. Here, don't in the test, let the machine do that. You could just label the top and let that be blank. It's machine's job now.
Right. Right.
Get to transparency, one of the best things personally I like about this platform. Go ahead, Pranay.
Right. Right, so do you want to understand why this platform predicted the way it did? EazyML's predictions explanation. So here is where you can choose a specific data point. Why did you predict particular candidate here survive or not survive? Let's say if you were to choose this one. Well, the model predicted not survive because of the following condition. There is no family on board, and plus, he happens to be a boy, a male. You take another data point in here, survive. Why did this particular individual survive? Well, because it happens to be a girl child, sex is female, age is 1 year old. So despite being the fare low, that means the class must have been, passenger class must have been class 3. Despite that being the case, the fact that it's female child survived.
So see now, this is what I meant in the beginning. You've got all these studies that you have had to read for class and or by interest. If you conduct a small little experiment and now you can gather data and have the machine tell you what the data is telling. Hopefully the data will align with what those studies are saying. But in some cases, it may not. And so you will have new insights as to when those studies are actually applicable and when they're not. The beauty of explainable AI, which is as transparent as this machine. So please capitalize on it. It will help you appreciate what you're learning better if you can conduct a small little experiment around what you're learning to determine how accurate are the studies and under what conditions are they truly applicable.
Right. Here, when you look at this local importance plot, this is different from global importance. So if you were to look at, if you recall what the global importance was versus what you see here as local importance, the distinction is this plot tells you what is important in making decision about this particular record, this particular data point, as opposed to the global importance. So here is another cool thing. You may be wondering about this particular button all along, trace. That's the other dimension of transparency. and that's called traceability. You can trace the entire session, the choices that you made and the choices that machine made on your behalf as part of this entire, start to finish journey. So in here, when we built the model, if you recall, this is where the global importance plot was. Sex was important, 54% importance, versus the class 17%, versus the fair 16%, versus the age 14% now.
So the key here is what Pranay is explaining is, you know how iterative process it is? So you did something and you're getting some results and you're scratching your head saying, darn, what did I do? I thought it was better the last. Well, for that, go back through this trace function, look through the whole thing and see what you did the last time and what you changed this time. And oh, that's what I did. Okay, next time I'm not going to do that, but I will still experiment with this. You have the full context.
Right.
Okay. So Pranay, I know we have only
a couple minutes, and we are at the end of the entire journey for a given data set, one data set.
Yeah, so I think we had planned for another data set to show you how strong the NLP power is, but we wouldn't be able to do that. Would you be able to bring up the slide, Pranay, about the competitions?
Yes, just give me a moment.
So I see that a lot of you have signed up at GroupMe. We encourage you to ask questions, engage with us. We will be posting more contents. As I said in the beginning, we are going to be hosting challenges and competitions, and there will be, cash prizes and internship opportunities, and we encourage you to engage with the platform. And if we see, students engaging in the platform, we are going to answer your questions, and there will be a lot of opportunities for interactions, and we will also offer a couple of months of free premium membership to those students who engage with us. And one last thing I wanted to mention, as we all know, that women are underrepresented in technology, and I'm very passionate about promoting women and doing my part in closing that gender gap. So especially those female students who are very interested in learning machine learning, I encourage you to reach out to me, and we will be very happy to help you learn machine learning using EazyML.
Mita, a quick question. Somebody in the chat asked where the video will be posted.
I will post it so on the website, and I will put the link on the GroupMe group, our EazyML GroupMe group, and it will be posted on the personal section, and I will send a link to everybody.
Great.
Okay. Any other comments, Arjun? As I said, also, this is the first in the series, and we hope things get back to normal, and we hope that we get to meet all of you in person, during fall semester, and during our next session. Until then, we hope that you use EazyML and you engage with us, and please feel free to ask any questions.
Yeah. And a big shout out to Arjun. Thanks,
yes,
Arjun,
thank you
for organizing, and thanks for all who made time to sit through this. We appreciate it.
Yes, any questions, do not hesitate. Yes, was there a question? Nathan, go ahead.
Yeah, thank you for the presentation. I just had one question, which was, does the platform have any capacity for unsupervised machine learning?
That's a really good question. So it's on the roadmap. If we had time, we would show you the unsupervised learning magic that we have pulled off for something called a customer insight manager. I'll just give you this in 30 seconds. There are so many solutions out there, right, that do customer analytics, voice of customer, customer journey analytics, a whole bunch of solutions out there. They do not answer the most fundamental question about customer service, which is, did you resolve the customer issue? Simple question at the very heart of quality assurance process. Did you resolve the customer issue? No answer. From all these tools out there, there is let's say there's something on it standing on its own today for unsupervised that has enabled us to answer that question. And in the roadmap, it's going to migrate into EazyML as unsupervised learning. But I wanted to bring this up because we keep talking about NLP prowess, and Amelia and what it does. Well, here's a real life example of what it means for an enterprise. And so, yes, it's going to be. It's not there yet. If you really are keen, maybe we can figure out how you can access this stuff using APIs.
David, you go.
So as we use the Titanic today as an example data set, do you have any recommendations of areas to find good sample data sets to work with your tool?
Absolutely, absolutely. We have some data sets on our website, and we will put some more. And we will, Pranay, you want to add something? We can, go ahead. Pranay is showing you.
Right there on the website, you have this data set repository. So it's an ongoing process, where we keep putting more and more data sets in here. So there are some here for the personal, there are some here for the enterprise. Some of these standard ones, which most data scientists, students are familiar with, and some interesting ones, like which came directly from either our clients or the research community, right? So they are all in here, both in the personal section, just a few of those, and in the enterprise as well.
Yeah. So we would encourage you to also visit the enterprise one, enterprise EazyML site. There are some data sets there as well. And we are going to put some more data sets on our website, as well as the GroupMe chat.
Right. And in one of the future sessions, we can take our journey into the text analytics. So some of these data sets have the textual content mixed with the numeric and categorical content. And text analytics, in a way, it goes into the unsupervised learning, unstructured data analytics part also. Any other questions from anyone?
Yeah, Jared, you have a question?
Yeah, one question I have is there any privacy or security with the data that we input ourselves? So say you get a CSV file from a company and they need it to be confidential so no one gets that. Do you have any data protections, or how do we know that that data is not going to be get in the hands of someone else?
Right, so all of these APIs, or whether you are using the portal, it's HTTPS, secure HTTP. And if it's an enterprise, the instance of the EazyML platform is hosted for that enterprise in the private cloud. For the personal usage, it's a shared private cloud, but everything is securely isolated for a given user. So one user would never be able to see any other user's assets. Three different kinds of assets here. When you go to developer portal, you will see there are three different assets, and they belong to you. It's your property, your assets. Nobody else will be able to see those.
Awesome. Thank you
Even
very much.
the APIs are accessible or secure channel. Does that answer your question?
Yes, that's perfect. Thank you.
Okay.
Any other questions? I just wanted to give a shout out to Arjun. Thank you, Arjun. I don't know if this group is interested. We are open to taking more questions. Arjun, what?
Yeah, so I think maybe we can sort of wrap up. So I know we had one more data set planned. So maybe so I think some students have left. If students want to stick around, we can go through that other data set. Maybe if students can put their hands up if they want to go through another data set, and we can kind of see. I know it's our budgeted time is up. So if not, we can kind of wrap up here, and I'm sure we'll have sessions in the future.
Yeah.
So maybe it's probably best to sort of wrap it up here for now.
Okay.
So to EazyML, thank you so much for taking the time to host this workshop, and we're really excited to continue working with you, and I hope that to the students that this was useful, and that you get the chance in your projects and in the things that you do to use EazyML, because it's a really super cool platform, and especially the explainable AI part I find really fascinating and really cool to watch. Yeah, so I think we'll kind of wrap it up here, and definitely look forward to future events with EazyML in the fall of various types, talks, workshops, internship opportunities, competitions, prizes, all things like that. And if you want to hear more about that, you can join the GroupMe. And Princeton Data Science, I put links to the Facebook page, to the email listserv, so definitely join those if you want to hear about future events. We may have a couple more talks this semester. If not, we're going to be having many more events come the fall, so make sure to do that as well. And I think, Mita, unless there's anything else that we want to cover, maybe we can wrap it up here.
Yep. No, thank you. Thank you very much to you, Arjun, and to everybody. And we are going to make the recording available to everybody as soon as tomorrow. And you can share with the group, and I'm going to put it on our GroupMe group. And you know, we would love to answer questions, and we would love to engage with all the students and see, you know, what they think of EazyML and how it helps them.
Yep, absolutely.
All right. Well, thank you so much, guys. Everybody have a good weekend, and thank you for your time.
Thank you, everyone.
Okay, bye-bye.
Bye.